Okay, so welcome back. Today we're going to talk more about the normal distribution and actually using it to solve problems, specifically probabilities. Okay, so we're going to use the normal distribution again, just like the continuous distribution, but in this case we can't use a formula because, like we discussed last time, there's no closed form for the probability function. So we're going to have to either use a table, what we're going to call the z-table, or we're going to have to use our calculator. Okay, so now let's start with a discussion of the table and in a review of what we're talking about probability. Okay, so when we have probability here, so remember we have a curve. Okay, and so here, remember, for a continuous distribution, we're representing the probability of an event or being within a range. So probability is going to be the area under the curve. Okay, so if I wanted the probability that a random variable x, so here x is normal with a mean of mu and a standard deviation of sigma, and I want the probability that x is less than or equal to some value of x, then this is the area under the curve, right? So how do we get this? That's the question. Well, if there's no formula, we're going to use either a table called the z-table, okay, which is a table of values based off of what? The standard normal curve. Because remember our conversation with chapter 2, we could take any normal distribution and transform it into a standard normal, just like we saw earlier in our earlier discussion. So that means we can use all of the values on a standard normal distribution to figure out the area under the curve, regardless of what distribution we're given, as long as we know that it's normal and it has a mean and a standard deviation that we know. That's it. So we could use the z-table, or we're going to use the calculator. And so I'm going to show you how to do both. So let's see here. Let's see here. Or, well, yeah, we'll do examples. So that's what we're going to do. So now let's start by looking at the table. Now in the textbook, and most textbooks have an appendix, or they'll have a flip chart or an insert that you can rip out of your textbook that has a z-table. Or you could just do a Google search on standard normal distributions or z-distributions PDF, and you'll find many different PDF versions of the standard normal distribution. Okay, so I'm going to talk through it. I'm not going to be able to show you what the table looks like, but I mean, you can look that up and just follow along, or just have your textbook. Okay, so now let's say I'm going to use the z-table. So the z-table is based on the z-distribution, right? The standard normal distribution. Okay? And so with the standard normal distribution, we get the z-table. And the z-table is what we're going to use to get probabilities. Now, we have to understand what probabilities does the table give us. The table gives us the percentiles. So in other words, it gives us the area under the curve to the left of the z-score. Okay? In other words, less than or equal to, or less than. Okay? So the z-table gives us the area to the left of the given z-score. Or it's a percentile table, right? So keep that in mind. It's always going to be less than, okay? So it's going to give us the probability that z is less than whatever given value we have. That's the probability that we're going to have. That's the only probability that the table will give us, which means we're going to have to, what if we want the probability of z being greater than some z value? Or what if we want the probability that z is less than some value and greater than another value? So in this case here, with the greater than, we're going to have to use the complement rule. So remember the complement rule. Okay? So if we want the probability or the area to the right, we're going to have to use 1 minus the probability to the left. Okay? And then for between, it's going to be, it's very similar to what we did with exponential. We're going to have to subtract the larger area. We're going to have to subtract the smaller area from the larger area. So the area here, so again, if we use this picture, then okay, we're going to have to take the area to the left of that z-score and subtract it, or excuse me, take the area to the left of this z-score and subtract it from the area to the left of the other z-score. Okay, so the smaller area or the larger area minus the smaller area is what I'm trying to say. Okay, so in this case here, we would take the probability of being less than z2, right? So the probability that z is less than z2, and subtract off the probability or the area to the left of z1. And that's what we would need to do. And so that's the sort of examples that we're going to be dealing with. Okay. Now the table that we're going to use comprises of a z-score. So the thing is before we can use the z-table, we have to be using a z-score. But not all problems are going to give us a z-score. Some problems are going to give us an x value and say that x is normally distributed with some mean and some standard deviation. In those cases, we're going to have to first convert the given x value to a z-score and then find the z-score on the table and get our probability. Why does that work? Well, think about it. Remember, any value can be translated into a z-score. So if I want the probability of some x value, right? So if I know that x is normal with a mean of mu and a standard deviation of sigma, and I give you some x value, right? Well, and here's what I want. So if I'm given some x value, I want the probability that x is, let's say, less than the given value of x, then, well, think about it this way. If I do this, right, if I say, write this probability out and I subtract off, what if I do this? What if I take x and I subtract off the mean and I divide by the standard deviation, right? And then I do the same thing on the other side of the inequality, and I take the specific value of x minus mu divided by the standard deviation. So what am I doing? I'm doing the same thing on both sides of the equation. Well, what is this piece here? Well, this piece here is the random variable z. And what is this one? This is the specific value of z. And so this probability is always the same as that probability. The percentiles will always be the same, right? Okay, so that's why this will work, right? So we're going to use the z-table to find the area to the left. Okay? So, with that in mind, let's do an example. And then I'll show you how the table works. So, let's say I want to find the probability that z is less than 1.4 using the table. So what I need to do is I need to find 1.4 on the table. Well, this is what we need. This is how you do it. So let's say this is the table, right? Well, you're going to have columns here. And we're going to have rows here. Well, the z-score is split up into two pieces. Okay? There's one piece that goes down the rows, the other one goes across the columns. So what happens is, if I have 1.4, it actually, what we're going to use is 1.40. And what we do is we split this up into two pieces. The ones digit and the tenths digit is one piece. So this is 1.4. And then the hundredths digit is split up over here, and we write that as 0.00. So what happens is we use this piece to go down the rows, and we use this piece to go across the columns. So what we do is we look for 0.00 here, but 1.4 we go down here. So what happens is, once we find 1.4 and then 00, we go down the column, and then we go across the row until we find the intersection of the row and column. And the number that's inside that cell, inside that intersection, is the probability. That's the area to the left. Okay? So if I look for on the table a z-score of 1.40, then the table gives me 0.9192. And we always go off 4 decimal places when it comes to normal distributions and the table. Okay? Typically, they always go off 4 decimal places, so I'll always write out 4 decimal places instead of 3. Okay? So 9192, what does that mean? Well, the area to the left of this z-score, 1.4, is 0.9192. Or the percentage of values that fall at or below 1.4 is 91.92% of all z-scores. Okay, so now, what about the next one? The next one, B says, what's the probability that z is greater than 0.74? Well, now, what am I going to do? Well, if I'm going to go down the column, right, so down the row, so down the rows, I'm going to look for 0.7. And then across the columns, I'm going to look for 0.04, right? So if I add these together, I get the 0.74. And if I do that, then what do I get? I find what? I find the probability of z being what? Less than 0.74, right? So the table gives me the probability of less than 0.74, which gives me .7704. Now, that's not the answer, because that's not what they're asking me for. They're asking me for greater than. The table always gives me less than. So what do I need to do? I need to use the complement rule. So this is going to be 1 minus the probability of z being less than 0.74, which is equal to 1 minus 0.7704, which is what? 2296. And that's my answer. Okay? So now, the next one asks me, well, what's the probability of z being less than 2.1 and greater than 0? Now, I know without looking at this that this answer is going to be close to what? What do you think this is going to be close to? I've got a number that's close to 2 here. This is 0. Well, I'm going to assume that this should be very close to 0.475. Why? Because I'm using the empirical rule here. I know within 2 standard deviations, what? 95% of all the values should be between those 2 values. Well, here I'm doing half of that, right? 0 to 2. So I would assume that this number probably should be close to 0.475. Let's see how close we are. Okay? So now, let's use the table. Well, remember, it's a between. So what I'm going to do is I'm going to use the probability of z being less than 2.1 minus the probability of z being less than 0. Well, what's the probability of z being less than 2.1? Well, if I look at the table, the probability of less than 2.1 is 0.9821. 0.9821. And the probability of being less than 0, well, that's going to be 0.5. Right? We know that. That's half, right? 0.5. Okay? So now, if I subtract these two, what do I get? I get 0.4821. Not bad. What did we assume based on the empirical rule? The empirical rule gave us 0.4750. Not bad. Not bad. See? And the empirical rule probably would have given us the right answer if we were using a multiple choice test. So that's one of the useful things is like on a test situation. If I saw this, I would have used the empirical rule and then found the answer closest to 0.4750, which would have been this one. Okay? Okay. Okay, next. Last one. Now, the probability, so D, the last one is probability that Z is between 2.43 and 1.21. Now, in this situation, I would not use the empirical rule because these values are too far away from whole numbers. Okay, so I'm going to use the table for this one. So probability that z, right, is less than 2.43 minus the probability that z is less than 1.21, right? The smaller area to the left minus the larger, I keep saying that wrong. The larger area to the left minus the smaller area to the left. So now I'm going to use the table again, right? So I'm going to look for 2.43. So remember, I'm going to look for 2.4, and then I'm going to look for 0.03, and I'm going to find the answers, right? So this is down the rows across the columns, okay? So 2.43, let's find it, 2.4, and then 0.3, 9924, so 0.9924 minus, now again, this is going to be 1.2 and then 0.01. So down the rows, across the column. So 1.21, 8869. So 0.8869. So what's my final answer? What's the probability of having a z-score between 1.21 and 2.43? Well, if we subtract these, what do we get? We get hold on. It's going to be one 0.1055. And that's the answer. That's it. That's how you use the table. Okay? Now, what about the calculator? Let's show you how to do the same thing using the calculator. Now, the function on your calculator, if you know that it's a normal distribution, is going to be just like in the binomial case, we used binom PDF or CDF function. We're going to use normal CDF. Remember, only the CDF function. Why? Because it's a continuous distribution. So we're not going to use the PDF function unless we wanted to graph out the curve and see what the curve looked like. Other than that, when it comes to probability, we're only going to use the CDF function. So the function on your calculator that you're going to use is normal CDF. So again, you're going to go to second vars, right? So you're going to do second vars to go to your distributions. And then under your distribution menu, you're going to go to normal CDF. And that's it. And the only thing you need to remember is what goes into your normal CDF. 4 arguments. Okay, the 4 arguments you need to put in this order is going to be your upper bound, upper bound, lower bound, and then your mean, and your standard deviation. That's all you need to put in. So the cool thing about using the calculator is, one, you don't have to worry about calculating z-scores. Okay? As long as you put in the correct mean and the correct standard deviation, it will calculate the area that you want. Also, you don't have to worry about subtracting areas under the curve, because all you have to do is put in the boundaries of the area you want. So unlike the table where the table only gives you one value, the probability of being less than or equal to or less than, and if we want the probability of being greater than, we have to use the complement rule, or if we want the probability of being between 2 values, we have to subtract areas. You don't have to do any of that with the calculator. All you have to do is put in the upper bound and the lower bound. Oh, rather, sorry, I got that mixed up. It's lower bound upper bound, sorry. Lower bound followed by upper bound. So as long as you put in the correct boundaries, you'll get the correct answer. That's it. So that's all you have to do for these. So let's calculate the probabilities of these z-scores again. So for A, so we'll do it again for these things. So we're going to say probability that z is less than 1.4, probability that z is greater than 0.74, probability that z is between 0 and 2.1, and the probability that z is between 1.21 and 2.43. So we're going to calculate each one of these using the calculator. So this one here would be normal CDF. And now here's the thing. We're using z-scores. So z-scores, the upper and lower boundaries, you can usually go out, because what's an outlier? 3 or more, right? Typically, the tables only go out to 4 at the most, -4 to +4. So what I usually do is when I'm dealing with z-scores, depending on what I'm asking, I'll use an upper bound of 1,000 or a -1,000, and you'll see why. So for this example here, remember, the normal distribution goes out to infinity on both tails, right? So if we look at the normal distribution, one of the properties about the normal distribution is it's centered at the mean, but the tails go off to positive infinity and negative infinity. So the tails never touch the graph, okay? So when it comes to the calculator, that's one of the reasons why we can't get a closed form for the calculating probability using a formula, because there's no way to figure out the area under the entire thing. Okay? We know it has to equal 1, but it goes off to infinity nonetheless. Okay? So with that in mind, well, how are we going to do the lower bound here? Well, we can't go off to infinity, so we're just going to do, if we're talking about a z-score, we're going to use either +1,000 or 10,000 or a -1,000 or -10,000. Usually that's what we're going to do. Now, if we're just talking about x values, and we're just talking about a distribution of x values, then what we're going to do is we're going to use 10 to the 99 to the 99th power for the upper bound, or we're going to use -10 to the 99th power for the lower bound. And again, I'm going to show you examples so it'll make complete sense when I show you the examples. So here we're using z-scores. So the lower bound is what? It's going to be 1,000, or -1,000, okay? Because this is the upper bound because it's less than. So the lower bound is going to be -1,000. The upper bound is 1.4. What's the mean and standard deviation for a z-score? You should know that. Without me having to write anything down, you should know that we're talking about the standard normal distribution, right? Because it's a z-score. It should be automatic. So what's the mean and standard deviation of the standard normal distribution? 0 and 1. So the mean is 0, standard deviation is 1. So what's the answer? Well, let's just go to the calculator. Let's go to second bars. It's number 2 on your menu. Number 2 is the normal CDF. Hit enter. And so now I'm going to put in -1,000. Make sure you use the correct key for the negative sign. Don't use the subtraction sign. So then it's going to be comma, 1.4, comma, 0, comma, 1. And I get 0.9192, which is exactly what we got before. Same answer. Okay? So make sure that you get the right answer. Should always match with what we got in the table. So now let's do this one, 0.74. Okay, so this will be normal CDF. Now it's greater than. So it's greater than. So what's the lower bound for greater than this number? Well, this is going to be the lower bound now. So now the lower bound here is 0.74. Now in this case, what's the upper bound? Well, it goes off to positive infinity, so we're going to use a positive 1,000 in this case. And then 0, 1 again. By the way, if I leave off the 0, 1 on the calculator, the calculator assumes that you want a z-score. So it'll assume 0, 1. I always put it in, but if you leave it off, that's fine too. Just remember, make sure you're looking for a z-score. So now, if we go back to the calculator, and we go to second vars, number 2, and now we're going to put in 0.74, comma 1,000, comma 0, comma 1, and we get 2296, which is what we got before. Yes, and we didn't even need to use the complement rule in this case, right? No complement rule. Now, what about this one here? So normal CDF. Now, this is the lower bound. This is the upper bound now. So we just put 0 and 2.1. So it's going to be 0, comma, 2.1. And then, of course, the mean and standard deviation is 0, 1. So 0, comma 1. And what do we get for this one? We're going to use, okay, .4821. And now the last one, same thing. We're just going to use normal CDF. What's the lower bound? 1.21. What's the upper bound? 2.43. And what's the mean and standard deviation? 0, 1. And let's do it again. So we're going to do second vars, normal CDF, and we've got 1.21, comma 2.43, comma 0, comma 1. And we got 0.1056. Okay. Now, notice that some of these may be a little off from what we used in the table. Remember, the table gives us out 4 decimal places, and the calculator doesn't round. But we should always get very close to the same answer. Okay, usually out to 4 decimal places for accuracy. Okay, I believe we got 0.1056 for this one here. So this one was the same one, right? This is the same. This was the same, and 1 second here. And then this one we got 1.55. So this is the only one that was off by a little bit. Okay? But that's it. So that's how you use the calculator. Much easier using the calculator. And the only thing we did was we just put in the right argument and we get the correct answer. So a lot faster than using the, it is a little faster than using the table. The table is easy to use, in my opinion, but the calculator is easier and faster. So let's see here. What else do we want to use? Now, let me stop there. So what I'm going to do is I'm going to stop there. And when I come back, we're going to do some more examples. But this time, we're going to use examples of using the table and the calculator for when we have to do a conversion, right? For example, what if I give you a random variable that's normally distributed with a particular mean and a particular standard deviation, right? So what if I give you this situation, right? Well, in this case here, to use the table, I'm going to have to convert it to this, right? And then from here, oops, hold on. So I have to go from here to here by using the z-score formula. And then from here, I can go to the table, the z-table, and then define the probability. So the probability, right, if I want the probability of x less than or equal to some value x, I'm going to have to use the z-score formula to go from this one and then find the probability that z is less than z, right? Just like I showed you before. So with the table, I have to do this conversion. With the calculator, I don't have to, as you'll see. Okay, but we'll do that next time. Okay, thanks and have a great day.